All right, well, welcome everyone to another webinar brought to you by Decide Solutions. I am your presenter, Jared Spaniel. I'm out of the Fresno, California office. Today we're going to be talking about designing with SOLIDWORKS mold tools. So let's go ahead and get started and go over some of this. Just a brief overview of what I want to cover today. We'll talk a little bit about the goal of what I want to convey to you guys. We'll look at the mold tools commands that come within SOLIDWORKS. We'll look at a high-level workflow of the how to create this mold tooling. We'll go into SOLIDWORKS and actually create some tooling and walk you through that workflow. I'll show you some stuff on where to get your complete molds and how to go about finishing those molds. And then I'll look at some tips and tricks of what I've learned researching this topic and playing with the mold tools, building some tools and stuff like that. So my goal today, to educate users on mold tool commands and the tooling modeling workflow within SOLIDWORKS. So hopefully to give you guys a pretty good high-level overview of what you need to do, the tools, what they do, and how you go about creating your injection mold or blow mold tooling. So I want to start off by releasing this poll question just to kind of get to know my audience, see what you guys are doing out there in industry. So what is your level of familiarity with SOLIDWORKS mold tools? So I'm going to go ahead and launch this poll. Appreciate if you guys just take a quick second and throw an answer in there. You know, you're very familiar, used it many times, you're somewhat familiar, you're familiar, you maybe use it occasionally, or you're not familiar, you've never used it. So I'll leave that open for about a minute or so and see what kind of audience we have here. So it looks like some of the results are stacking up, and we've got almost half the audience in attendance is not familiar or never used the tool. A small percentage is very familiar, and then we've got a few other scattered points within the middle here. So that's really good. That's good to see that a lot of you guys aren't familiar with it. So hopefully you'll learn some stuff today, and then you can begin to implement it. So I'm going to go ahead and close this poll out. Thank you for answering. So let's move forward. So the mold tools commands. So if you didn't know, mold tools is included with SOLIDWORKS standard. It's a basic tool that's included, just like sheet metal or surfacing or any of those other types of things that come within SOLIDWORKS. So you access it just like you access the other tabs within SOLIDWORKS by right-clicking on the tab, selecting mold tools to turn it on and off. Now what they give you out of the box with the mold tools commands is, first off, they break it down into a few sections, which I've highlighted here on the screen. The first one they give you is the surfacing stuff. So that's kind of a repeat of the tools or the commands that are included with the surfacing tab, but they put those in here as well because a lot of the stuff within mold tools does deal with surfaces and surfacing creation, but a lot of the actual mold creation tools themselves take care of that kind of more or less automatically. So I don't normally use those surface creation tools within the mold tools options, but there is another entire separate workflow that you can use those surfacing tools with exclusively to create molds. We're not going to go over that today because I wanted to concentrate on just the mold tools themselves because they're very powerful. The second kind of segment they give you there is the model preparation stuff. So this is a couple of your analysis tools like draft analysis, undercut analysis, the scaling, the split, you can add draft, stuff like that. So a couple good tools. We're going to look at a few of those within SOLIDWORKS. The next segment they give you is the actual mold creation commands. So these are like how to create your parting line, your shutoffs, your parting surfaces, how to actually split your tooling, do your cores. And the beauty of this is SOLIDWORKS is intuitive enough to put these actually in a order that goes along with the workflow. So if you ever get lost, you can kind of see where you're going there from left to right on how everything should flow or follow along, and I'll kind of show that within SOLIDWORKS as well. The last category there is what I like to call the hidden tools, because by default those aren't actually placed on your command manager. So this is a snapshot of my command manager that I customized. So they have a couple other tools that are highly added value tools that you don't normally see. And these are like if you're doing mounting bosses or snap hooks, if you're adding vents, lips and grooves, anything like that, they have automated commands that actually do those. So you can place the things and then customize within a command manager, and it makes it really simple to place those really common features. Now, of course, you have to go into the customizing options, search for those tools, and then pull them out and add them, drag and drop them, add them to your command manager. But be aware they are there. You just have to look for them. So the workflow for mold creation it's a quite extensive workflow, but it can be broken down into a few smaller steps, but I wanted to give you as many steps as possible here. I always like to show the workflow toward the beginning of the webinars, just because it gives you guys a high-level overview of how things operate and how they work. And as engineers, we love that. We love to see those high-level overviews of all the steps laid out, or at least I do. So you always start, obviously, with an opening or importing model or creating your own model. Then you can use the fix file options for the translation errors. So those are like your feature works, feature recognition stuff. Always want to check for correct draft. Verify that you have correct draft, and then if there isn't, you can fix the undrafted faces either with the draft command or in the actual feature itself, if it is a feature. Then we want to scale the part. So this is to account for our plastic part shrinkage. They give you a nice option in there to automatically scale things to account for that. Then we're going to establish where we want our parting line to be, or where we want our mold tooling to actually split from our A side and our B side, or our front half and our back half, however you like to call it. Then we'll establish create some shutoffs. We can also look at the shutoff analysis tool, which if you don't already know where your shutoffs are going to be, it'll help you kind of visualize what you need to have in there to create the shutoffs. Then we're going to create our parting surface, which is just basically a ruled surface, so another surfacing command but built into this parting surface command. We can develop interlocks, and then basically we're going to separate the tooling into an A side and a B side. And then we can save out the individual parts, the individual bodies as parts, and then you would go on to kind of completing your mold, the actual mold plates, the mold tooling, with some other options that I'll kind of talk about toward the end there. So that being said, just wanted to see if everyone's still awake out there. Got a little knowledge test here to see what you guys kind of know. Question, all plastic parts should include drafted faces to some degree in the direction of pull. I'm going to go ahead and launch this. And if you'd please just take a quick second to answer, quick true or false there. It's not a trick question. And then after this, we're going to talk about what actually draft is and how SOLIDWORKS looks at draft. And then we'll jump into SOLIDWORKS and actually do some mold tooling creation. So I'll leave this open for a few seconds here. Looks like mostly everyone's pretty much voted. So I'm going to go ahead and close this out. Mostly everyone answered true, which is correct. That's true. Pretty much every surface on a plastic part should have some degree of draft in the direction of pull. It's totally true. So let's go to the next screen here. Talk a little bit about draft and draft analysis. So my bluff here, if you don't know what bluff means, it means bottom line up front, and greater draft equals less potential for ejection issues, which is what we just said. The surfaces should have draft, right? So I just want to give a brief overview of some draft stuff, draft recommendations. These guidelines vary depending on the sources you look at. If you look at textbooks or anything like that, or if you look at specific websites of companies that manufacture tooling, they may have their own guidelines as well. So I've seen anything basically range from half a degree to several degrees. So I've seen sources say 1/8 degree to up to 6 degrees. But normally 2 to 3 degrees is totally fine if you're not concerned. A couple things that the draft angles do depends on the material, depends on your product design requirements and how that's going to affect your overall dimensions. If you anticipate any ejection problems in certain areas, you may want to have more draft in that area. The size of the part or the surface texture. If you have a really, really large part, you're probably going to want some more draft on there. If you have a really, really rough surface texture, you're probably going to want some more draft. If it's a very smooth surface texture, you can probably decrease the draft angle a little bit. And then you want to select a face or plane normal to the direction of pull to specify your draft angle. So this is a brief example of the part we're going to look at here and how SOLIDWORKS calculates the draft, just to show what it's actually showing. We're calculating the draft off of the top plane or this top surface here, and then we have green is positive. The yellow color lets us know that we require draft in that area, and the red color is a negative draft. And we'll go ahead and look at that in SOLIDWORKS, but I just want to quickly show that. And this is the part we're actually going to be working with today. So I'm going to jump right over to SOLIDWORKS. I selected this part basically because it's a common part that pretty much everyone sees. You can walk through Walmart, Target, any store and pretty much see these types of baskets. They're pretty much everywhere. It's a very simple part made likely from a commodity plastic, and it also illustrates all the points and the workflow really good for what I want to show as far as creating the parting line, parting surface, the tooling, and then coring out a few areas, creating those shutoffs and all that. So it's a great example part to kind of show an overall workflow here, right? So I'm not going to go into any of the part modeling. I just modeled this part up. It's very simple. But what I am going to show first here is the draft analysis that we just looked at. So in this case, I can consider this a relatively large part, so I'm going to call it 6 degrees of draft. I want to specify, I know my parting line. This one's very self-explanatory. I know my parting line is going to be this surface, right? And it shows me my arrow in the direction of pull here. Lets me know that I have good draft. I have negative draft on this side, which I want, and positive draft on the inside. Now, if I didn't have that draft here, I could add it by utilizing this draft tool, or what you can do is actually go into the feature. So in this case, I have my basket lip feature. If I jump into this feature, you can see I can actually add this draft or take it off within that feature here. So that is right here by adding the draft. And you can see I specified my 6 degrees of draft on that surface already. So if I didn't have that on, it would give me that yellow warning letting me know that I don't have draft on that surface. Okay, so let's kind of look back at that workflow, think back to that workflow, right? Remember how I said it kind of moves from left to right here? So the first thing we're going to do is grab this scale command. I want to do uniform scaling about my centroid here, and I'm going to make it a 1.02 scale. So when I hit the green check, you can see it enlarges my part ever so slightly there. The next thing that we want to do is actually insert our parting line. So I'm going to use this parting line command over here on the left. Grab that parting line. It's asking me for my direction of pull, which I want to do this surface. I want to have my draft specified at 6 degrees. You can also run the draft analysis right here as well, and it'll show you everything that's good. So it basically shows me the same thing that the draft analysis tool shows, but within the parting line, just to re-verify. My colors, green, and then my red on the outside. Now my holes here are blue. I'm not going to worry about those because I know I'm going to be coring those out. You can do some more stuff in here. If it's not, SOLIDWORKS is pretty intuitive that it will pick up everything on its own, but if it doesn't, you can always adjust these on your own, or if you have crazy surface geometry that's not straightforward, you can adjust things on your own. You can also split some entities, stuff like that. So I'm going to hit the green check, and you'll see that I have my parting line showing up around my part. So that's kind of the step one. The next thing we want to do is do our shutoff surfaces. If you don't know where your shutoff surfaces are going to be, you can utilize this undercut tool, and it automatically selects my face. It automatically populates my parting line, and it tells me where my shutoff surfaces are essentially going to be. So it tells me I have an occluded undercut. I have 44 faces, and these are the red faces here on this hole pattern around my part. So I know that I'm going to need a shutoff there. If you don't know where your shutoffs are going to be, this tool is great. It's pretty obvious in this case that I'm going to need some type of shutoff to create this. So the next thing I want to do is actually do my shutoff surfaces. So you can see I did parting line. Now I'm going to do my shutoffs. Now, in this case, something very interesting is happening here. Normally what SOLIDWORKS does is it picks up the correct edges to shut off. But in this example, got some weird stuff going on here that I really don't like. So I'm going to actually have to select things manually, because you actually have to think here in this case how you want your part to be shut off. If I select these outer edges as my shutoffs, what that will actually do is it will create this geometry on my core side, which I don't want, because if that geometry is created on my core side, I will not be able to get this part out of my mold once it actually injects. So what I actually want to do here is I'm going to have to select these inner surfaces of my part manually. So you actually have to think in some cases. Normally SOLIDWORKS is really good about picking these lines up or picking these edges up. But in this case, because of the way that it's selecting them, it's actually giving me the wrong edges. And normally it gives me the correct ones. So just be aware of that. You can normally trust it, but make sure you know what you're looking at and what you actually want to shut off, because what this is going to do is it's going to create a surface for me on the edge that I actually select here. Oh, I don't want that one. So I want surfaces to be created on each one of these holes. Now, unfortunately, in this case, I have a rather complex pattern here, and I wish it would pick up everyone, but I just have to go through and select these so I can establish the correct shutoffs here. So bear with me for a moment while I just pick all these surfaces, or pick all these edges up. Okay, so now I've got all my edges picked up. Tells me I have contact, which is fine in this case. There's a couple options in here for different patch types. You can use tangent or all contact or all no fill. I want all contact in this case. I'm going to leave this as is. Gives me this nice green box here letting me know now that my mold is separable into a core and a cavity, which is good news. That's what I want to see. I'm going to hit the green check mark. Takes a quick second because I have so many edges here. And now what you'll see is I actually have these surfaces created on the inner side of my part, which is what I wanted. If I would have done it the opposite way, I would have had surfaces on the outer edge of my part. So when I create these cores later on, I would have just had a flat core here, which I do not want. I would have had that geometry would have actually been on my cavity. So it is a bit confusing, but just be aware of that. And now you'll notice I have a couple folders starting to develop here. I have my surface bodies folder with my two shutoff surfaces, and I have my parting line under my solid bodies folder. So next I'm going to move to my parting surface command. What you'll notice, I want to be perpendicular to pull in this case. It automatically populates my parting line box here. And one tip around this area is when you actually use this parting line command, you have to be aware of what your tooling sketch is going to look like. So in this case, I've had a little forethought and I've actually created my tooling sketch beforehand. You can always do this later and come back and adjust this. But what you want to be aware of here is that I actually need this parting surface to extend out past my tooling surface like that. If you don't do that, it'll likely give you a warning saying that it can't create the tooling split because your parting surface hasn't extended past your tooling sketch. So if you know where you're going, you have forethought in this case, you can create your tooling sketch ahead of time. If you don't, you can just drop a parting surface in there as it was shown, then create your tooling sketch later and come back and verify that your parting surface extends past your tooling sketch. There's also some smoothing options in here for, you can do a sharp or a smooth. In this case, it actually doesn't matter too much because I just have a flat kind of surface here. This is more if you have like L shapes and stuff like that. You always want to try to keep it as smooth as possible due to machining. Like, you don't want sharp corners. It's going to be really hard to machine, and it also causes weak points in the part. So I'm going to hit the green check here, and now my parting surface is created, right? The other little tip here is you can turn off, they have specific selection tools for parting lines and parting surfaces in here. So if I actually don't want to see my parting line or my parting surface, I can turn those on and off in here. Or you can go over here and hide those things as well. So my parting surface, I really don't need to see that. I can hide that away. What you'll notice also is I have a kind of a multicolored part. These are just the cavities and the cores overlaying on the part. So I have a red part, a green part, and then my actual part here. One's a cavity, one's a core. So if I look here, I can either hide these or show individual ones. So now I turned one off. So one cool thing about mold tools also to note is this is going to be your friend, the hide and show button here, because you might need to look at certain things or not look at certain things when you're actually working in mold tools, and you need to know what you're actually looking at when you're jumping around, because you're going to have tooling overlaid with a cavity surface, a core surface, and then your actual solid part body as well. So the next thing I wanted to look at was the tooling split. So we're pretty much ready to split this tool. I'm going to select my tooling sketch that I already have pre-created, do my tooling split, and it shows me a nice preview of what my tool is essentially going to look like, or my cavity and my core blocks. Automatically selects everything for me. My shutoff surfaces are my cavity and my core, and then my parting surface is, of course, my parting surface. So I'm going to go ahead and select the green check here. Now what you'll notice is I have my tooling created, right? So if I grab any of these and do a hide and show, you'll see my part in there. Now I don't want to actually see my part, so I can hide that. So you'll see my cavity and my core now. You can do a bunch more hiding and stuff, but let's go ahead and finish the rest of the part off, or finish at least some of it off. So now we've got our tool ready to split. We need to figure out how we're going to make those circle patterns on the sides that I talked about before, right? So I'm going to go ahead and utilize this core tool. So I already have a core sketch created on the side of my part. You can see that it's an angled sketch along that face of the basket. I'm going to grab that sketch. First, I'm actually going to hide this bottom half. And then I'm going to do the core, sketch, core. So now there's a few things to note within here, right? This isn't as intuitive within SOLIDWORKS because it's picking up a few of the wrong things I actually don't want here. I don't want to do this face. I actually want to do an edge here. And I don't want to do this parting line. I want to do my core, or my tooling split. Now you can see I have actually an angled core here. If I look at this from the side, I don't want this to be angled. So actually I want to specify this edge, which it cleared out for me. And then I want it to be through all. You can do blind or through all. I want it to be through all my entire tool, or my entire A half here. So that's what I want it to look like. I actually want to select tooling split 1 in this case, and the edge to make it parallel with that edge. So it should be normal to this plane. So I have this nice angle here, and then flat right here. So I'll check out of that. So now what you'll notice, it's back to the hide and show game here. If I show my core, and I show my tooling split, you'll see that I have a complete tool here. Now, of course, I need to do the exact same thing on the other side, so I would go about doing that, another sketch on that face, and then creating another core. But this tool is actually pretty much complete, so I'm going to jump over to the completed version of it and just show you exactly what it would look like. So in this case, I've completed the same exact tool. I've got both cores done, and you'll see my feature tree now reflects that workflow we were talking about: parting line, shut off surface, parting surface, then we split the tools, then we did our cores, left to right here. I'm going to show the exploded view of this. So if I explode this view, what you'll see here is both my cores, 1 and 2, my tooling, A and B half, my cavity side, or my core side, excuse me, and my cavity side, and then my part. So this is what part will be created within here. And you'll see I have flat surfaces here. Now this is what I was talking about before about selecting those correct edges. If I had selected the outer edges, I would have had these circle geometries on this part, which I would not want in this case, because you can imagine, like I said, when this is closed, if I inject, all of this plastic would fill around those circles and I would not be able to retrieve my part. So I always want to make sure that I have the surface geometry, what I'm trying to actually core out, or my undercuts on my cores. So in this case, I selected the correct edges, and my shutoffs are on my cores. So these would retract and extend to create that part, usually on some angled pins or something like that within the mold, right? So this is what the completed mold tooling would look like in this case to make this part. Of course, I would need to add my ejector pins on the bottom here, and my sprue hole, and my locating ring, and my runner, and all that stuff. Well, the locating ring would be on the complete tool, but I would have my runner and my gate, my sprue, and all that stuff on this half, and my ejector pins. So I'm going to jump back over to my PowerPoint and give you guys some tips. So on the complete mold, I'm obviously not going to go through the entire complete mold just for the time's sake today, but you don't have to actually create this geometry yourself. You can download it. If you guys are on subscription with us, 3D Content Central, a great place to get this tooling. You can go in there and customize molds to your size, to your liking, grab different ones. I just picked a standard manufacturer mold. Everything in there has a complete 3D view powered by eDrawings. You can grab the 3D and the 2D and customize all the dimensions, and then just download it. And then you would take what we just created, our cavity and core blocks, cut them out in the tooling, drop them in, add the rest of your geometry, pop your ejector pins through and all that stuff to basically complete that total tool. There's a bunch of suppliers in there that they have with different tooling options. It's easy to download, complete parts and assemblies, or of course you can go to a manufacturer vendor if you have someone that you use that provides the 3D models to get the complete tooling, right? So some tips and tricks that I want to pass on to you guys, some things that I noticed and have learned over experience. Try to follow the prescribed workflow as best as you can. You can run into some potential issues if steps are missed. Now sometimes you can always go back in the feature tree and change things, but sometimes if you try to change geometry or change different things later on down the line, you may run into an error or an issue, and you may have to kind of adjust some things. So if you stay along that workflow like I showed, usually it flows pretty smooth. So there is a lot of forethought and a lot of kind of thinking in mold tool design and how you're actually going to create the parts, create your correct cores, create your shutoffs, any other geometry that you want to have in there, especially if it gets to be pretty complex. Use the built-in tools to check yourself. So the draft analysis, select your face or a plane, normal the direction to pull, verify your surfaces are drafted correctly before you move on and start creating your mold. You check the shutoff analysis. If you have very complex parts, you may want to look and see what it's telling you as far as where you need shutoffs. Utilize the proper part scale to account for part shrinkage. So of course this is based on your material, but it's nice they have that quick scaling tool just to add that in. Pre-create your tooling sketch to know how big to make the parting surface. We talked about this a little bit. If you already know how big you want your tool your cavity and your core blocks to be, you'll know how big to make your parting surface. Now you can go back and adjust this pretty easily. If you forget, you create your tooling sketch later, you can go back and adjust your parting surface, but that is a pretty common error that I see where people put that parting surface in, they just leave it as the default or really small, then they go on, they create their sketch, gives them a warning or an error saying that it cannot create their tooling. It's because they didn't make their parting surface big enough to encompass their entire tool. And then of course you can download your complete mold from online content to save yourself time. You don't need to go ahead and model all that extra geometry and tooling. You can just customize that as you go and as needed, and then drop that into SOLIDWORKS, drop your cavity and core blocks in, and pretty much be done with it. Another quick reminder is to always utilize rounds and fillets appropriately for your mold design. This is pretty self-explanatory for machining, but make sure that you're rounding stuff and filleting stuff in your tools. So thank you guys for attending. I hope you learned something. If you have any questions, you can email me at jspaniel@decide-solutions.com or contact our tech support at techsupport@decidesolutions.com. And just reminder to think about how SOLIDWORKS mold tools can help you with your upcoming projects. So thank you, everybody. Have a great Wednesday. See you next time.